In this video, I am going to solve this problem. We are given cosine of alpha plus secant of alpha is equal to 5 over 2. We need to show that cosine to the power n alpha plus secant to the power n alpha is equal to 2 to the power n plus 2 to the power negative n. The strategy to solve this problem is this. We are going to take the given condition cosine alpha plus secant alpha. Then from this we are going to do some algebraic manipulations, and then we are going to try to find the value of maybe cosine alpha. Okay, once we find the value of cosine alpha, we know what is the value of secant alpha, and then we are going to plug it into the desired equation, which is this one. So let's get started. So we can write this as cosine alpha plus secant alpha is 1 over cosine alpha, as you know. That's going to be equal to 5 over 2. Now I am going to multiply both sides of this equation by maybe cosine alpha, 2 cosine alpha, maybe that's going to be easier. So multiply this by 2 cosine alpha, multiply this by 2 cosine of alpha. So using the distributive property, 2 cosine alpha times cosine alpha is going to give me 2 cosine square alpha, then plus 2 cosine alpha times 1 over cosine alpha is going to just give me 2 is equal to, now on the right hand side 2 and 2 are going to cancel out, that's going to give me 5 cosine alpha. If I bring the 5 cosine alpha to the left, I have 2 cosine square alpha minus 5 cosine alpha plus 2 is equal to 0. This is sort of like a quadratic equation in cosine alpha. Now we can just factor it and solve it. So 2 cosine square of alpha minus 4 cosine alpha minus cosine alpha plus 2 is equal to 0. Look, I have taken this negative 5 cosine alpha and I have broken it down into 2. Negative 4 cosine alpha, negative cosine alpha. So in essence, I took this sort of like trinomial and converted it into a quadrinomial so that we can factor things out. Now between the first two, I could factor out 2 cosine alpha. If I factor that out, I'm going to be left with cosine alpha minus 2. And between these two, if I factor out a negative 1, I'm going to get cosine alpha minus 2. That's equal to 0. So I can factor out cosine alpha minus 2 since it's common to both. Cosine alpha minus 2. If I factor that one out, I'm going to be left with 2 cosine of alpha from the first term minus 1 is equal to 0. Now the product of two factors is 0. So one of them must be 0, right? Or at least one must be 0. Or it could be both 0, but not necessarily always. So now cosine of alpha minus 2 is equal to 0. That implies cosine alpha is equal to 2. But this cannot happen because remember, sine or cosine values are restricted between negative 1 and positive 1. So this is positive 2, so it doesn't work. So this one is not acceptable. Now the other one is 2 cosine of alpha minus 1 is equal to 0. If I solve for cosine alpha, it's going to give me cosine alpha is equal to 1/2. So this is the value that we are going to take. Cosine alpha is equal to 1/2. Now if we know cosine alpha, we can find secant alpha. Remember, secant alpha is equal to 1 over cosine alpha, which is going to be 1 over 1 divided by 2 or 1/2. So that tells me secant alpha is equal to 2, right? 1 over 2 is 1 times 2 over 1, right? Which is just 2. So now I found the secant alpha and I found the cosine alpha. Now what I am going to do, I am going to take this value and plug it into the left hand side, which is this, which is cosine of alpha. So that's cosine to the power n alpha plus secant to the power n alpha, and cosine to the power n alpha. So cosine alpha is, remember, cosine to the power n alpha is the same as cosine alpha raised to the power n, and similarly secant to the power n alpha is the same as secant alpha raised to the power n. However, the convention is to write it this way. Okay, so just to give you a heads up on this. Now we know cosine alpha is 1/2, which is right here. So it's going to be 1/2 to the power n plus secant alpha is 2, which is 2 to the power n. Now I can simplify it. I could write it as 2 to the power n plus 1 over 2 to the power n is the same as 1 to the power n over 2 to the power n, using the rules of exponent, right? Remember, a over b to the power x is a to the power x over b to the power x. So that's what it is. So now this is the same as 2 to the power n plus 1 to the power n is 1 divided by 2 to the power n, which by the way is the same as 2 to the power n plus 2 to the power negative n. Now remember, in going from here to here, I have used this formula, or rather definition. 1 over a to the power x is the same as a to the power negative x. This is a definition, okay? So remember that as well. So these two are properties of exponents. Now, by the way, this is the same as the right hand side, isn't it? So we just showed that cosine to the power n alpha plus secant to the power n alpha is equal to 2 to the power n plus 2 to the power negative n. Now let me summarize what I have done and how I have done it. So let's go back and touch on it again. This was the given condition. I just took the given condition and then I break down secant alpha to 1 over cosine alpha, and then I just multiply it by 2 cosine alpha and convert it into a sort of like trinomial in cosine alpha, and then we factor it and we come up with two values for cosine alpha. One is cosine alpha is equal to 2, but that cannot happen. As you know, cosine alpha is limited to positive 1 and negative 1 values, in between negative 1 and positive 1. So 2 is bigger than that, so that cannot happen. So our only solution is cosine alpha is equal to 1/2. Then secant alpha is 1 over cosine alpha, which leads to 2, and then secant alpha is 2. Now I take the left hand side of the given desired equation, which is cosine to the power n alpha plus secant to the power n alpha, and I plug in the values of cosine alpha and secant alpha and simplify it, and I finally get this one. So that's what it is. I hope that this discussion was helpful. Thank you very much.